So hello everyone. Thanks for showing up for this conference, for this talk, and thanks to the Symfony crew for inviting me over today. So before actually getting into the presentation, I would like to introduce myself. Well, you introduced myself really well. So yeah, I don't sing, but I do PHP. I've been doing PHP for the last 6 years. I'm a 10 certified PHP developer. I'm also a certified Symfony developer. And I'm the co-organizer of the Symfony, which is a Symfony event in Spain. Last year, we managed to gather 400 people in there, so quite a big event. And right now, I'm working in Writester, which is a company doing video on demand. But before that, I was working in Timeout. And the whole thing about this presentation is actually my time at Timeout when we were trying to implement continuous delivery. So that said, before actually starting, I would like to say that by no means I consider myself a guru in continuous delivery. So actually, this presentation is more about how we struggle and what we learned in the process of actually implementing continuous delivery. So I don't expect you to have, the presentation is not meant to be a theoretical approach to the subject, but actually more how we manage to do so. Okay. So the agenda for today is actually really simple. So we are going to be covering 3 things. The first thing is basically a really short introduction to the continuous delivery topic. We will see what it is and what's basic foundations about that. The third bit is building the pipeline, which is basically the main topic, the main bulk of the presentation, which are the things that we did to implement continuous delivery in a Symfony project. And the third bit is actually how our life was different at Timeout before and after implementing the continuous delivery pipeline. So, what's continuous delivery in a nutshell? So basically, continuous delivery is a set of tools and rules that you have to follow in order to get your code from your source code into your production environment. And the black box in the middle, this is the continuous delivery pipeline. So the continuous delivery pipeline is actually made up of 4 different steps. The first step is the commit phase, which is basically at what point and how you decide that a change in your source code is going to start kicking off the pipeline. We will see later on how we did that in Timeout. The second step is the build phase. In the build phase, we check for the integrity of the code, which is pretty much making sure that your code is the right thing. Things like you could do here are things like running your unit test or compiling the code if you were using something like Java or C. So the important bit about the second phase is at the end of the build phase, you will have something called the artifact. And the artifact is, in PHP world, is nothing more than a zip file. And we will see that later on. But that's the important bit, the artifact. After that, you have to test. You have to test not that your code is working fine, but actually the project as a whole, it works properly. So when you are building a PHP website, your website will have to connect to a database, it will have to talk to an API, and it have all sorts of integrations. So this is the kind of things that we are going to be testing in this third phase. So after these 3 steps has been passed, you are 100% confident that the thing that you put in your source code is actually able to be deployed to production. And the last bit, of course, is the deployment. So the deployment is basically, I've done all that step, and now I'm going to put my code into the production environment. I don't know if you can tell, because it's really small, but that's not an arrow. That's a straight line. And it says here manual. It means that in continuous delivery, the last step, going from testing to deployment, going from test to deployment, is actually done manually. It means that the person, it has to click a button. And it's important that it's just clicking a button. It doesn't mean 5 people doing something at the same time during 2 hours. It has to be really, really simple. I don't know if you are familiar with the continuous delivery and continuous deployment. So the main difference between continuous delivery and continuous deployment is that in continuous deployment, this goes straight from here to here. There is no manual step. In continuous delivery, there is one person that says, OK, that's fine, looks fine, go ahead, deploy it. Okay? So that's the only difference between continuous delivery and continuous deployment. So as I said before, this is the theoretical approach that I'm going to be taking for today. If you want to know more about, in general topic, what means continuous delivery, I would recommend you to read this book. This is like the Saint Grail of continuous delivery. It's quite a big book, but in my opinion, it repeats the same things again and again, so it can be a little bit boring, but it's quite interesting because very much it covers all the different scenarios, whether you're doing Java to PHP to C, whatever. Okay. So that said, let's go to the second bit of the agenda today, which is actually how we manage to implement the continuous delivery in timeout. So before actually seeing how we implemented that, let me introduce the tools that we were using in order to accomplish our goal here. So the first one was, we said that we have to put our code in some sort of code repository. So at timeout, we were using Git supercharged with GitHub. If you are using Subversion, I'm sorry for you. What can I say? So yeah, we were lucky because actually GitHub allows you to do a lot of, basically it's much better than Subversion and you can deploy faster, in my opinion. You can, develop faster. So the second thing that we were using was Jenkins. Who here is using Jenkins for, okay. So for the few persons that didn't raise their hands, Jenkins advertises itself as a continuous integration job server. Continuous integration server. In my opinion, it's more than a continuous integration server. It's basically a job task server. So basically, you ask Jenkins to do something, and it will do that for you. It can be running your unit tests, but it can be fetching the latest version of the code or getting a backup of the database. So basically, we were using this bit, we were using Jenkins to implement all the different steps of the delivery pipeline. For Jenkins, we were using a couple of plugins. Basically, Jenkins is based on this plugin infrastructure when you can basically add new features, new functionality, just getting something from the internet and installing it into the Jenkins server. So we were using there is a plugin for GitHub, which is basically listening to Git, to the GitHub repository and making sure that there is a new change, checking for new changes in the source code. And the other plugin that we were using was the pipeline plugin. And the pipeline is basically, you have different jobs in Jenkins, so you can kick off one job after the other, and you can see all of them together. So you can see that after this job, it has run the other job, and it hasn't run the other job. Okay. So the third bit that we were using was Ansible. Is anyone here familiar with Ansible? So is anyone here familiar with the concept of provisioning servers? Okay, cool. So basically, we were using Ansible for two things at timeout. We were using Ansible for provisioning servers, which is basically making sure that you have the right software in the right servers. And actually, we were using Ansible to deploy to production. I think it's easier to read and to understand that things like Epiphany, but that's a personal taste. On the other hand, we were using Amazon Web Services, especially we were using S3. And basically, we were using S3 as a repository for holding our artifacts. That, as I said before, it's just a zip file. And the last thing that we were using is Thing. Anyone here familiar with Thing? OK, so for those of you that don't know, Thing is basically a task manager. So you said, I want you to do this set of things, and I'm going to write everything down in XML, and then Thing will go and run it. OK? So how did we build the pipeline? So we said that the first bit is, as you can see here in the bottom right corner, we have the 4 steps that we defined before in the definition of the continuous delivery pipeline. So the first phase is the commit, which is basically when are we going to kick off the whole process. So in timeout, we were using Git flow, but we decided to simplify everything and to go for the simplest solution to say when we kick off this pipeline. So we have master, which is the eventually stable branch. And a developer picks up a feature, a user story. It starts working on that. It commits something. And after that, he said, OK, my code is good to go. I want that to be merged. He goes through the pull request process. The pull request will get accepted, or it will get rejected, or wherever. But at some point, this will get merged into the master branch. So at this point, Jenkins, as I said before, we had a plugin that was listening for this Git repository. And when it noticed a new change, it was kicking the rest of the continuous delivery pipeline. So that's it, as simple as that. I would recommend you not to have any fancy merging strategies here. The simpler, the better, in my opinion. So once we know that something has changed in our source code, the next bit is the build phase. So what were we doing there? So checking out the master branch, generating the parameters.tiny for each of the environments. So if you have a QA environment, you have a production environment, you have a staging environment, you have a test environment, we were generating one of these for each environment. The third bit is fetching the dependencies. Two things: if you are going to be using Composer for fetching these PHP dependencies, two flags that you should be using in Composer. The first one is the optimizer autoload. It takes a little bit longer to generate the autoload.php, but the lookup of classes is going to be faster. And the other one is preferred dist, because we are running that on the Jenkins server, so we don't actually need the Git repository. So this preferred dist is just going to fetch the files without all the .git directory. After that, we run the PHP unit tests. Then we fetch the JavaScript dependencies. Nowadays, it's very common to be using things like npm or grant to get all these dependencies. So we were running that as well in Jenkins. Generate the assets and generate the artifact. And as I said before, we have now in Jenkins, we have in the workspace, we have all the files, and it's basically getting everything into a zip file. That's it. And it's important that when you are generating this zip file, you make sure that you rule out all the files that you don't need at all. So for example, the test directory, you won't need that. Or the .git directory, you won't need that. So the less weight that you have, the easier it's going to be to upload that later on. And the last bit is actually, once we have everything into a zip file, this is the artifact, we put that into S3. All these different steps, they were actually in the build.xml, which is part of Thing. So if you've never seen a build.xml before, this is how it looks like. So for each of the steps I mentioned before, we have one of these different targets. And as you can see, trying to understand what the target is about is really, I think it's simple. So you are going to print out a message here, and then after that, you are going to run a command in the console, in terminal. So that's it. So at this point, we have basically what we've done is we fetch everything from the master branch. We have get all the dependencies, and then we have put that. We make sure that the code is right, so the unit tests are passing, and then we put everything into S3 in a zip file. After that, we want to make sure that not only the code is right, but the integrity of the project as a whole is correct as well. So we are going to be testing two things here. The first one is going to be testing the deployment of the script. We want to make sure that we can deploy this artifact properly. And obviously, we are going to deploy that to the QA environment. And then we have to run the automated test, which is making sure all these integration tests that we have, making sure that you can talk to the database, making sure that the API is there, making sure that all the other things that are not basically code. So for testing the deployment script, so basically, what we want to do is SSH to the QA server, fetch the artifact from S3, and zip the artifact, set the right permissions to the log folder, to the cache folder, to the document root and everything, update the virtual host, and reload PHP, FPN, and Nginx. This is basically your deployment script. You have, at the end of the day, it's moving PHP files to the server. That's it. So we were using, as I said before, we were using Ansible to do so. And Ansible looks something like this. So everything in Ansible is pretty much a YAML file. And again, you can see that you have the tasks here, and then you have a name and a thing that you are going to be doing. So you can see that here is when we are fetching the artifact from S3, and here we are going to uncompress it and apply the right permissions and restart. This is a real file. This is not an example one. Really, really simple. So at this point, we have deployed the latest version of the master branch into a QA server. So we have to make sure that this is fine. This is working fine. So we are going to run our automated test. To do so, we were using Behat. So again, we check out the master branch, we fetch the PHP dependencies for testing, and then we run the bhat against the QA box. So that's it. So at this point, you pretty much are completely sure, or quite sure, that your application is going to be working fine. So the deployment phase, which is actually getting your code into production, is nothing more than running the same deployment script that you run against the QA box, but this time to the production environment. And after that, because you have that in place already, you can run the automated test again to the production environment. So you deploy, and after that, you check again that everything is working fine. OK? So just to sum up a little bit, so this is the process again. So GitHub, something changes, and we get the git commit as the unique identifier for this build. So in the build phase, each of these green boxes in here, it represents a job in Jenkins. And the thing is that we are going to be using the same box, the same job to do different things. Basically, you can have parameters in the job server, in Jenkins. So you are going to be using the same thing to do two different things. So in the build phase, we are going to generate this artifact, which is going to have the same, the name of the artifact is going to be the commit plus .zip, that's it. So we can identify it uniquely. If this is fine, it's going to kick off the next step, which is the deployment to the QA box with this unique identifier. If everything goes fine, we are going to kick off the next step, which is running the automated test on the QA box with this unique identifier. If this goes fine, we'll mark this artifact as successful. So after that, we are happy to deploy that. And in here, there will be a person, because we said before that the last step, which is deploying to production, is going to be a manual process. So there will be a person here that will have to kick off these two steps. So in the first, it kick offs the deployment bit for the production environment with this unique identifier, and then automatically this will run. Okay. In here, in timeout, the person that was doing this bit was actually a person from product. So it was a person that didn't know anything about, it wasn't a technical person. Obviously, if you ask a person from product to deploy something to production, they are going to freak out. So we added a safety net, which is pretty much a staging environment. So the process was as follows. The person in product wanted to deploy something to production. So before doing that, this person was deploying that to the staging environment. She was quite happy with that, and then it only has to repeat the same process in the production environment. So basically, this was just to make sure that everything goes fine, and if something goes wrong, you haven't messed up on production. Okay. So I said before that we were generating the one parameters.ini per environment. So we had a parameters.ini.qa, parameters.ini.production, parameters.ini.staging. So we can go for two different options in here. So the one that I just described, or the other bit is actually injecting this specific parameters configuration through the virtual host. I don't know if you know that you can do that. It's really handy. If you haven't read anything about that, it's really interesting because basically you have the same parameters.ini, and this dependency, well, this specific parameter is injected by Apache or Nginx. So you basically don't have to keep different files. So I'm not sure which one is the best option, to be honest. At the end of the day, it depends on your company. So what about timing? So this is how much time it was spent in each phase of the process. So basically, generating the artifact was taking roughly about 3 minutes, which is good. You have to have in mind that the project was relatively small, so that's why running all the test suite was relatively fast. The deployment process was 30 seconds. If you think about that, it's just fetching something, SSH into a server, fetching something from S3, unzipping it, and restarting Nginx. Shouldn't be more than this. So 30 seconds, 20, depending on. And the last bit is running the automated test, which was about 5 minutes. Again, this was early days for us in here, so probably this will grow quite a lot. We were running just like 10 or 20 user stories for the automated test. But obviously, the more you have, the more time it's going to spend in this phase. OK? And after that, if everything goes fine, then it's marked as completed. So when you are building the continuous delivery pipeline, it's important that it's visible. It's visible by everyone in the team. So what we do was we have a bigger screen in the company, in the department, that was showing the status of the pipeline. So we have something like this. So here you can see quite easily that, so if this is in order from latest to newest, so we can see that the last bit has completely, has been successful. But here, the build phase, something failed. And here, something in the deployment script was wrong. And here, there was some automated tests that were failing. Okay? So it's important that everyone in the team is able to see that it should be in a big screen somewhere. And also, we were using this thing here, a light. So if everything was fine, this was showing the status of the latest commit. So if everything was fine, this was green. If something was in the process of getting built, it was yellow. And if something was wrong, this was flashing red. So, I mean, this kind of things makes a little bit more interesting to work in that. So the other thing is traceability, because basically you are going to be deploying things to QA without you knowing that actually you are deploying to QA. Or people in product is going to be deploying things to staging and production. So you need to make sure that it's really, really easy to see what version has been deployed in what environment. So the trick that we went for is this header here. So whatever page you request, there will be a next timeout v header that will contain the git commit. So once you have this information, you can go to GitHub and see what are the changes. So as you can see, you can have a release document for pretty much everything. So this is quite handy. And people in product, they were asking what this release contains. So we just were pointing them to this URL. And there you can see it, because in theory, the commits will be meaningful. And it will have something like a user story, whatever, adding new feature to the user. So you can go through the whole log and see what's actually in there. Rolling back, obviously, this is not a perfect roll. Sometimes shit is going to happen. But rolling back was actually straightforward. Rolling back was deploying again the previous version that it was there. So it was another 30 seconds. That's it. And before you get all very excited about continuous delivery being the best thing ever, and you want to implement that, I want to warn you that you will need allies. So unfortunately, this is not something that one person can do by himself. So who are your allies? So the dev team. It's important that everyone in the technical team buys into this option. Because you don't want to become the continuous delivery guy. You go for holidays for 1 week, and when you come back, you realize that the whole thing has been broken for 1 week, and they were waiting for you to fix it. So that shouldn't happen. As long as the whole thing breaks, the whole team should get involved and trying to fix it as soon as possible. You also need the QA team needs also to commit to this. In some companies I've been before, there were a lot of manual testing. And the QA team needs to understand that they have to start doing a lot of automation. So they have to be happy doing that. And also, they have to trust these automated tests. Because there will be a person in product that will be doing the release. And you are going to be running this automated test, and this is going to be your quality stamp to say that something is fine. So the QA team has to be comfortable with all these automation processes and automation tests. DevOps also needs to be part of this as well. So it's especially important for 2 things. So basically, most of the time, the people writing the deployment scripts is going to be DevOps. So it means that they have to be keen to sit down with one of the developers to work out what's the best strategy for the deployment process. And also, DevOps need also to embrace all these provisioning tools like Ansible or Chef. Because if you want to trust this thing, you have to make sure that your stage environment is a clone of your production environment, which is a clone of your QA environment. And there is no way to do so unless you have things like Puppet or CloudFormation or Chef in place. And this takes time, and not everyone is actually keen on implementing all these provisioning tools and all this scaffolding. So product needs also to buy that, because as I said before, it's going to be product at the end of the day, the person that is going to be deploying the project to production. So if they don't want to take this responsibility, then that's something that you should bear in mind as well. And obviously the brass. And what I mean by the brass in here, so basically CTO, head of department, all these big heads in the company. Because basically you are going to be working on, when you try to implement the continuous delivery pipeline, you are going to be working on something that no one is going to see for a few months, because it takes time to put all the things together. At timeout, we were really happy. It was really good that the CTO was actually the person pushing forward to this. So that's good. And that's it. This is how we did it. As you can see, in the big picture, it's nothing really, really fancy, but it takes time to plug everything together. So how did our life change before and after implementing this thing? So the first thing that changed for us is having the QA box. So before implementing the continuous delivery pipeline, we had pretty much one QA box per developer, which was really, really complicated because QAs, the testers, were running around asking, what's in this box? What's in the other box? Have you deployed that to the other version? So it was really hard to follow what's going on. In here, we only had one QA box. And we were sure that this QA box had the latest version of master. The other good thing about this approach is that we didn't have any late integration issues. So do you know that some people is working on something, and they are working on something for 3 days, and other people is working on another something for 3 days, and then when they have to put everything together, you're going to, probably this person haven't done anything for 4 days, and 1 week later tries to put it back, but without realizing that something did something before, and then it's like, whoa. And then you spend 2 days trying to fix what should be relatively easy. So yeah, one QA box, and everything goes to the same bucket. So you make sure that when you are testing the thing, you are testing the whole thing. No, I'm just testing this bit. So the other interesting thing is, since a developer was working on something until this something was deployed into production, before implementing this pipeline, it was taking weeks. When I mean weeks, I mean 1, 2 weeks. After that, it was a matter of days. So the developer was working on something, it was working on that something for 1, 2, 3 days, and after that, it was merged into master, and off it goes. It goes to production, or it went to production as soon as possible. So before doing the continuous delivery, we needed 5 people to release to production. We needed 1 sysadmin, 1 QA, 1 release manager, one developer, and eventually, sometimes a database administrator. After that, it was 1 people. And actually, it wasn't a technical person at all. So that's good. So running these deployment scripts to deploy something to the production environment was taking roughly 30 minutes because it was a mix of automated scripts plus manual checking. So roughly 30 minutes doing the whole thing. After that, as I said before, 30 seconds. So quite a lot of improvement. Before that, releasing was an event. And what I mean by it was an event is something got released to production, and after that, 1 email sent out to the whole company, we just released something. Can you just make sure that everything is working fine? After that, releasing was done pretty much every single day. So it wasn't this kind of event. And that's pretty much it. Before leaving, I would like to thank to Timeout for giving, even if I'm not working at Timeout anymore, they gave me the opportunity to talk about that. And to Reister for giving me the day off today and actually helping me with improving this presentation. So that's it, pretty much, and thank you to everyone. Any questions?
Hi. How you manage the database migration?
That's a good one. I knew someone was going to ask us.
Is it the part of the deployment script, or it's going on production somewhere?
I have to say that I was cheating all the time. Because this was a new product that we were building at Timeout. And basically, we had a product for the API and another product for the website. And the website was consuming the API. So we didn't have to manage, database migrations. But if you have to, then you have to run them during the deployment bit, the deployment script. And the one thing that I didn't mention is, if let's say that you run your migration script and something goes wrong. So the other thing that you should be testing, I said that we were testing the deployment script and we were testing the integrity of the project. But you should also be testing that your provisioning scripts are working fine. So one thing that we wanted to do, we never did it, but we wanted to, is when we were releasing to a QA box, we actually were provisioning from scratch the whole QA environment. So that means that you are going to start with a fresh database, you can run the migration script, and if something goes wrong, then you know that the next time that you deploy something to the QA box is going to be a fresh copy of the production environment. So that's how you can test all the migrations with confidence in the QA environment. But obviously, this takes time, because you have to put a lot of things together. Does it answer your question?
Hi. What were the reasons behind continuous delivery instead of continuous deployment?
Because product wasn't that confident on us. I mean, if you think about that, it's really scary to say a random developer is going to put something on master branch and then off it goes. It goes straight to production. And on the other hand, at Timeout, they wanted to deploy some things at some time. So they had some timings. So I think it's fair, as long as you make sure that if you want to deploy something, it's something like, yeah, just go for it, do it. So that's good.
Hi. Did you have a dev environment within Symfony running any code?
How do you mean a dev environment?
Well, normally you sort of run your systems in prod.
Yep.
You certainly develop in the dev environment without caching, but then you also have the option of a test environment.
So
in the code itself.
So we were using, I don't know if it answered your question, but we were using Vagrant to actually create our dev environment.
Yeah, well, that's where you edit code, but in the Symfony app kernel, for example,
yeah,
most of the bundles will be in the sort of main top level where you pull in the bundles. You've got the option of putting in dev and test only bundles below it.
To be honest, I don't know. I mean, when we were running the test, we were running the unit test. And some integration tests were also part of the unit test. And because you can handle that with PHP unit. And this big integration test, which is basically, you have to actually check that it connects with the database. You have to make sure that all the integration bits are done properly. This was done in the third bit, which is the automated test. But
okay.
Hi, where does non-automated testing fit in the flow you described, like real people?
Could you repeat again, please?
So at what stage in your process, if any, did a human tester get involved?
Yeah. So usually that bit was done here. After that. So let's say product wants to deploy something. He thinks that for any given reason, it needs to be tested a little bit more. So he goes, put that thing on staging environment, and after that, he goes to the QA guys and asks them, could you mind doing more testing on that, doing some manual testing? So we were using that bit, and sometimes also that bit. So.
How did you know everything in that commit was tested?
Because you have unit test and user acceptance test. You are running everything after each commit.
So sorry, I meant the person who pushes the button to deploy to live might say to someone in the QA department, please go on staging and check that this feature is working. But in that commit, there might be 5 new features. How do they know that?
No, because they have this identifier. So for each commit, you are going to generate an artifact.
Right.
So now, when you have all these many artifacts, each of these has a different set of features in it. So the product person, have this list of artifacts that has been deployed. Yeah. So he can say, so here, let's say that the person in product say that here there is a message that contains the user story that she wants to be deployed. Yeah. So he says, okay, that's the user story I want to deploy. That's the commit number. So I want to Jenkins and deploy this commit.
Okay, cool, thank you.
So you make sure that you are not deploying all these things, but just up to the here.
That makes sense, brilliant.
Sorry if that wasn't clear from my presentation.
One more. If you had a large new feature that was committed in a number of commits, would you test each commit even though it may not be the full feature, or would you wait until a certain commit?
Well, the commits that were tested were the commits that were a merge commit. So when you merge something, these are the commits that you are going to build the artifact for.
Okay, but your developers might be squashing commits before they send it.
Yeah, that's the other thing, that when we were implementing the whole thing, we were asking people to rebase and squash things, because otherwise it's really hard to make it work. Sure. Also, sometimes a commit can make it into the master branch, and then you have to take it out. And it's so much easier if you are rebasing to take it out, and actually if you are merging everything together. So.
Okay, so your developers change their style of working to fit.
It's funny because implementing continuous delivery means implementing a lot of good practices around that. And it's not only that, but actually doing rebasing or having a background box to make sure that your development environment is as close as possible at production and so on. So unfortunately, we are running out of time. I'm going to be around. So if you have any question, please go and grab me. And thank you so much, everyone, for attending.